Welcome to the Digital Forester Podcast, where we talk to foresters about how they are using digital technologies in their day-to-day forestry work. Hey everybody, it's Kevin Lim from the Digital Forester Podcast. I just want to give you a heads up that we ran into a little Zoom recording glitch. Zoom apparently did not want to record me while speaking, but only the guest. So unfortunately, you don't get to see this guy on this YouTube podcast. I'm not sure if Zoom's trying to tell me I should get a haircut or something, but in any event, you will only see the guest, and that is normal. I hope you enjoy the show. Hey, everybody. Welcome to the Digital Forester Podcast. Today, I am joined with Dr. Guoliang Liu from aiTree. Dr. Liu, how are you doing?
Good. Thank you, Kevin.
Good to see you. Good to see you. It's been a while. I honestly think it might have been a Forest Tech event back in Vancouver a couple of years. Maybe the last time we connected.
We met in New Zealand and Australia.
That's right. That's right. Yeah. It's always funny how a lot of Canadians, we connect far and abroad versus, in our own backyard. So interesting enough, just before we started the podcast, you mentioned that you actually recently flew to China and you're there now. And it was a challenge to get there. So maybe for our listeners, because again, we have a global audience listening, maybe share some thoughts on what went smoothly on that trip and what maybe surprised you in your air travels, because a lot of us have not been in an airplane for 2 years. So I'm personally curious to know, is it the same once you get in the airplane, or is it that much more different?
The airplane is not bad, it's not that many people, So one person, you see, maybe you have the entire row seat. So, but a lot of tests, it's for almost 4 weeks isolation,
4 weeks. Wow. Yeah, because I guess China has the COVID zero policy, so they're very tight, and we'll get into it. You're in China because you mentioned you have a development center there, so we'll talk a little bit more about that. I always love learning more about where different organizations have their centers of excellence, if we want to call that, and who's doing who. But before we get into that, maybe to warm us up and get us going, master's forestry background, but definitely University of British Columbia, master's in forestry, as well as a PhD in forestry. But before you got to that point, maybe tell me, how did you get into forestry? Were your family connections were foresters, or just something you picked up? How did you discover the world of forestry?
I was a mechanical engineer. I was designing like a cable yarder systems before I came to Canada. So 30 years ago, I came to UBC and started with John Nelson, my teacher, and he is developing the models. Probably a lot of people know that. Even at that time, the computer only had 1 megabyte RAM, but they already have a really good model, called Atlas. So then I learned from him, right? I got into the modeling development field, that's. And then for the last 30 years, I still work in this field. Never change.
Yeah, that's amazing. So on the cable yarders first, and that's amazing. So you came to Canada, you're doing your studies, working with UBC. Did you ever think that you would still be in the field of forestry 30 years later? Was this always part of the grand plan?
Yeah, I still really enjoy it. We learn a lot of new technologies, and we keep learning new technologies. So we develop new models. Right now, we have like a cloud-based forest modeling platform, which you can build models in the cloud online. So you don't have to install a software in your computer, or you don't need, no matter where you are, what device you use, you can always run the model. So it's really good, the team working environment,
Right. So maybe that's a good segue. Maybe introduce our listeners to who aiTree is and what the company does. You're the CEO, the president of the company. So maybe for our listeners who may not know about aiTree, tell us about what type of technology is at play. I believe there's some optimization components, and then you mentioned the cloud, but maybe at a high level for our listeners, who's aiTree and what type of work are you doing and who are you serving?
So I have to say, you see, before I graduated from UBC, I work in a company called Hugh Hamilton Limited in North Vancouver. And then we split. We have another company called Forest Ecosystem Solutions. So with my partners, so we basically, I develop model, only use it internally, you know, for our own business. So, but 15 or 20 years later, I realized this can be very useful. So then we start another company called aiTree. So and focus on the software development. So then later I started another office in China. We hire like 12 software engineers. You know, now 10 years passed. So we have a cloud-based forest modeling platform. So that integrate, you know, AI, so big data, so that can make the forest modeling work easier and smarter. That's what we are doing.
Right. So when you say you're building forest models, is this along the lines of strategic planning and tactical planning? Is that the space, or is it more comprehensive of developing plans, but also you mentioned AI or artificial intelligence doing more? Maybe walk me through, because I'm keen to learn myself about your technology, but maybe go down one level and let me and tell me what it's all about. Why are people buying aiTree technology? What problems are they solving?
30 years ago, you know, when the computer only had like a 1 megabyte RAM, so the best you can do, you separate strategic plan with management plan. So because you cannot have so much spatial information, so that you have the best way you can do it is separate it. You do a strategic plan first, like Woodstock they are doing, right? They're still doing that. So you do a strategic plan. After you have a strategic plan, it's not a real plan, it's just analysis to give you how much timber you can harvest each year. And then you use other models like a tactical model or management plan model, so to allocate where you harvest. So the 2 or 3 process, 2 steps or 3 steps, that it's a lot of work, and it's difficult to link the strategic with the management plan. The work we are doing with FSOS, we call the Forest Simulation Optimization System, we integrate strategic and a management plan. But when you set up strategic goals and target objectives and constraints, and it automatically can tell you what you should do on the ground to achieve your targets. So I believe this is the future. They simplify the process and also reduce a lot of workload. At the same time, because the linkage, so you don't need to link them, they integrate. So I believe this is the future. That's why I really like called digital forest. That's what we call the digital forest.
Yeah, right, for sure. And so the headquarters of the company's in Vancouver, in BC, British Columbia. So is it safe to say, like, your clients, are they, you know, BC? I know Lakehead University in Ontario, you mentioned that they're using FSOS. I always laugh. It's always engineers who come up with these acronyms like Forest System Optimize. Wait, I already got it wrong.
It's a simulation optimization system.
Yeah, so an
simulation
engineer
optimization.
mouthful, FSOS. Yeah, absolutely. But BC's environment is pretty complex. So as we think about your technology, I believe you're working with a lot of folks in BC and elsewhere. So when we think about some of the foresters out there that may not be using this type of optimization technology, how do they get started? Like, so if someone was to come to you and aiTree and say, hey, Dr. Liu, we want to get involved with this. What are some of those things they have to consider? Like, is there a data component? Is it or do you just kind of take it all and it's unstructured and you make it structured and do something? But maybe walk us through the steps of Kevin is your brand new client, knows absolutely nothing. What are some of those things we have to think about and prepare before we could leverage your technology?
So you always have the first cover data. You start with the first cover data, right? You have, so you can collect the data with different ways, no matter how you collect the data. When you have the spatial data, all just the you don't have to do you don't have to have spatial data. If you want to do a spatial modeling like Woodstock, that's okay. So when you have the data, we provide all the tools to load the data, to do the growth yield curves, or load your own growth yield curves, and set up the constraints and targets. And the model will use we call a heuristic search algorithm to find the best solution, the best plan. So that's how that works. But we call them a digital forest modeling platform. Why? Because you can build model in the platform, build your own models. So it's online, right? So like Lehigh University is teaching this in the labs. So the professors, Kevin Crow and others, TAs, and they all told us, it works really well. I can talk more later, about that.
Yeah, no, for sure. So thinking of that, I love the idea of cloud. A lot of people are moving to the cloud per se. Are the cloud technologies that aiTree is leveraging like the Microsoft Azures or AWS's, or are they more private aiTree data centers and whatnot?
Yeah, we have a cloud server, in Vancouver. So we use so we call the Canadian Cloud right now. It's a company, a small company. We rent a server there, right? So the best thing is, you see, when you use cloud, like Lehigh University, in any other university, you may know that, for the computer labs, they always have hundreds of computers, students sitting by the computer, and a lot of technicians help you to install the software, maintain the software, maintain the machine. You can imagine that, and you can see the picture. Still, most universities are doing something like that now. But for Lehigh University, for this course they are teaching, they don't need the lab, the physical lab. So especially during the pandemic time, students and professors, they all work from home. How can you work together efficiently? So basically, we provide them a cloud-based lab. Every student had their own account to do their labs. Professors and TAs, they can share whatever they want to share, and they can see what each student is doing. When they have a problem, and our support team notice right away and solve the problem right away. So that's why the lab went really smoothly.
Yeah, right, for sure. So typically when we think about these types of technologies, and again, it makes me wish I paid more attention to some of my undergraduate computer science classes and simulation. And, we hear about linear programming, simulated annealing, and X, Y, Z beyond this guy's knowledge. But as a general forester, does it matter what method we use, and if so, what are some of the what is aiTree doing? I know you mentioned heuristics search, but maybe help our listeners, or help me understand the subtle differences and the pros and cons of the different approaches.
That's always the important part of a digital forest. For digital system, when you have a complicated system, you have a complex problem you want to solve. Usually, with linear programming, with traditional mathematics, you cannot solve because it has millions of variables. So hundreds, thousands of targets, objectives, and constraints. So you cannot solve that with linear programming. So that's why we use heuristic search. With digital forest, so when you have a complicated problem to solve, you always can build a digital system which mimic the real system. But for the difference is, you talk about maybe digital twins. You talk about, but this is different from digital twins, because the digital system can explore the opportunities, find a way to achieve your target objectives, and give you the road map, how you achieve your targets. And at the same time, accumulate knowledge, learn from the real forest, and improve the digital forest. So when you have digital forest, they can do a lot more. So it's not just like twin.
Yeah, interesting. So what I kind of heard is that you're feeding the model, as you go through time, additional data, and it can improve and get better. So thinking of data, we always talk about data, and I hate to use the digital twin, some might say, is a buzzword, digitalization, digital transformation, etc. But we think about data often, data is the new oil. Big data, whether it's really big data versus just large volume data. But in your world, in your company, how, because you're in this cloud thing, does the size of the data matter in terms of how your solutions run, or does it really not matter at all?
To me, the size is not that matter, because the way we call, you may not, they just term different buzzwords, right? So for me, I just accumulate knowledge. If you know forest analysis, forest modeling, so there are a lot of work, like growth and yield curves. They have been doing this for over 30 years. They do that for every project. But why don't you, the model should learn it, from history. When you do have a forest map, know where the location is, know what kind of tree is there, what kind of stand there, it should be able to give you the growth and yield curves. Why do you have to spend a lot of time to do growth and yield curves? So probably, in other words, be smarter when you accumulate knowledge and learn from history. And next time you do it, you don't have to do from the beginning. That's the main part I want to say.
Yeah, no, I love it. It's like work smarter is a common theme. Do things why, sometimes redoing things when there's an alternate way of doing it. So when we think about the services aiTree offers, what are maybe some of the common objections or obstacles you encounter with people who might say, oh, Dr. Liu, like, we can't do this, we can't do that? Is there some common patterns that you've seen? And if so, what are some of those? Because I'm sure many of our listeners may be going, oh yeah, but this, that, all the reasons why I couldn't do this. But in your experience, is there a pattern there that you've seen that's kind of repeated itself? And if so, what are those common themes on why people might not embrace this type of technology?
To me, I see it like probably you always talk about people are not willing to try the new things. This is probably important part. For me, it should be simple. Everything should be smart. When you do forest plan or strategic analysis, when you have the data, you load the data into the model. You tell what kind of object you want to have, like what kind of target you want to achieve, like biodiversity, wildlife habitat, visual quality, water quality, and the timber production, and the carbon sequestration and profit. So when you set up all these targets and constraints, you let the model run it and give you the best scenario. Of course, you can change the weight, try to get different scenario, but the digital forest should be able to simplify this work. You don't need for carbon accounting right now is a big problem, I think, because just like what I said, they separate forest plan with carbon accounting. To me, if you have a plan, you should know how much carbon is stored, how much. So why do you start another process, right? So of course, all the calculation equations, parameters should be used like from like the forest carbon modeling. Like in Canada, we have like a CBM. You probably know forest carbon model. So we use all the same equations, same parameters, but that can be integrated with the forest plan. So the first benefit, you simplify this work, you reduce a lot of work. And secondly, you can have carbon sequestration as one of the objective. You can optimize it. So to me, I think in the future, the work will be easier and easier.
Yeah, no, and thanks for sharing that. So for our listeners, a couple questions. So as I listen there, and you're like, you're familiar with the CBM. Explain that to our listeners. What does that mean? Because in some ways, I used to cheat. In my modeling work, will predict above ground biomass, and the extent of my model was just multiply by 0.5, and that's how much carbon's there. Right or wrong, it was the poor man's solution. But for our listeners, it's like, walk us through CBM, what that means, and then because then I do want to move you to talk more about carbon and get your views on, because there's a whole thing happening in the world right now. But for our listeners first, and especially our foresters, walk us through what carbon means to you and how you view it, how you model it, what's different in your approach. Obviously, your system's leveraging the CBM model, and I suspect other models to account for the carbon directly in your models. But for our listeners, walk us through CBM, what it means, and why it's critical in terms of how we predict carbon.
So CBM is well known, in the world. Every country, probably even in China, I know they all know this model. A lot of people are using it. It's really good model because it gives you a lot of details. But for forest plan, so we have to be able to simplify that. We can plan our forest. We can increase our carbon. Like reduce the fire, reduce the insect and disease. So you can start from the first plan. So even start from planting trees, you can include that part, how you can stabilize the carbon in the forest, in the wood products, increase the carbon. At the same time, you can produce more wood, you can have more profit. And at the same time, you also can balance with other objectives like water quality, water habitat. So this is really complicated. That's why I think digital forest is the solution for these kind of problems. So because it's too complicated, people it's hard for people to understand it. But if you build a digital copy, a digital force, you can see the future. You can see what you do on the ground now, how that impact the future. That's one thing. You can forecast, predict the future. Another thing, if you have if you use heuristic search, use other smart optimization algorithm, you can generate plan to achieve your goal, achieve your objectives. So not only forecast, you also can generate plan. So that's the you see that how the digital force can help you. That's
absolutely. And so I'm curious to know your thoughts. There's, it's interesting to hear you comment on that, because, when I talk with other folks, there's excitement about carbon, exchanges. There's groups out there that are using remote sensing to model inventory and then predict carbon for offsets, per se. Are they doing it wrong?
no.
What do you think about that?
See, that's the one thing is when you talk about digital forest, people have different definition. They understand it differently. So to me, no matter what kind of a method you use to collect the data, you can use remote sensing, you can use LiDAR, you can use air photo, you can go to the ground, collect the data. It does not really matter to us. So the work we are doing, we use the data you collect and build a model to forecast the future, to manage the future, to create the future. We are not collecting data. Of course, data is important. Data is important. You can collect. If you have a better way to collect data, that would be nice.
Right.
We don't do that part. But in the future, maybe. So we can, if we have the opportunity, if we can build a connection, that would be nice directly.
Right. So really, if there's good data, whatever that data is, it's fed as input into your system to build the model and then forecast forward or predict into the future. Gotcha. For sure. Very cool. So on that note, I want to maybe shift gears, and this is the Digital Forester podcast. So a lot of people are keen on hearing your views on technology in general. So I think this will be kind of fun, because you mentioned you've been at this for 30 years or quite a while. What are there certain technologies that you kind of knew were coming, and in the early days you're like, yeah, something's going to come and it's just a matter of time? Are there some technologies that maybe just caught you completely off guard? And when I say technology, it's kind of broad in the forestry sector in general, not just optimization and software, but in general, like thinking early days, like obviously GPS, right, was a game changer. Now we kind of take it for granted. It's in our smartphone, everything we work. But maybe share with us some of your thoughts from your earlier days, your younger days, and then flash forward to now. What are some of those key technologies that really you feel has transformed forestry?
You see, to me, the technology we use, it's not new, like for simulation, optimization, heuristic search, the new technologies is new. So we call metaverse. You heard that, and you see the metaverse, like a Facebook, right?
The metaverse, yep.
Yeah, but to me, I understand differently. People always talk about VR, AR, and games, or blockchain about the metaverse. But to me, if you can have simulation, optimization, you can have a dynamic system like a digital forest, you can see the future. And so you can, if you can use the digital forest technology, of course, you can include, you must have optimization algorithms. you have if you can combine with VR, AR, you can see the. But right now, for the digital forest, what we are doing, we can see the future. We can see how much timber you can harvest each year. We can see where the trees are, and what function of the forest you have at any point in the future. But it's not a VR. It's not like you cannot walk. You can walk into the forest, the future forest. But I see if we can use this kind of technology, so we can see the future, we can walk into the future, we can feel the future, we can find a way to create a desired future. So that's the new technology. It's probably not new, but the technology is there for a long time, but we just, how we apply them, how you explain them. But for me, I have been doing I've been doing the forest modeling for so many years and apply the algorithm to solve different problems. But just until last few years, I really understand how those really important problems can really help a lot of industries.
Yeah, no, thanks for sharing those thoughts and your vision there. And I'm secretly chuckling or secretly laughing inside, because often in a lot of my podcasts at the end, I ask people about what they think about the metaverse, blockchain or crypto. And I always joke, because some people are like, why is he asking this? So this is refreshing. I didn't have to ask you. You're bringing it up. And so what I think is really what I think I know is really cool is when we think about VR, virtual reality, AR, augmented reality, the metaverse, is the digital twin, is the metaverse the reincarnation of the digital twin in a different form? I don't know, but it's a compelling story to say we already have technologies to have an immersive experience. And if your technology can essentially build a model to then build a better future, if we want to call it that, and you're able to link these technologies, that's kind of cool, because you can walk through the forest, you can create different scenarios to see what that looks like, move beyond just a screen and your mouse and your keyboard, but maybe don a HoloLens or use some an Oculus Rift or something for a Meta, the new Facebook type of thing. That's some cool stuff. That's kind of mind-changing per se. But what do you think are the challenges of getting there? Like, forestry is not really a sector that moves very quickly, embraces technology and just runs with it. They've been early adopters on a lot of things, but some might argue things have slowed down. They're not really innovating quickly enough. So how do we get to that future state that you've described? What are some concrete things that you need to see happen for you to further invest in aiTree technology development? What are those things you need to see happen within the sector?
Yeah. So I still think the digital forest is the future. For the forest sector, we are not slow. We have been doing forest modeling for over 30 years. So, and many other fields, they have not started. So just talk about it. But the forest industry, we already, especially in Canada, we have been doing forest modeling since when I started my graduate program at UBC. My teacher, Professor John Nelson, already have the really good model. So even that time. So today, but I have to say that today we need to do more in the forest industry. 30 years ago, the computing resources is, the limit. We can't do much better. 30 years ago, so we have to approve improve our technology is, let people know it, accept it, learn it, use it. Right now, I know it's not easy, but then people, they get used to it for like 30 years. It's hard to change. That's a big challenge. Yeah.
Yeah, definitely. I totally relate to that. So maybe let's look to the future. What are some of the technologies that get you really excited? So we've talked about, AR, VR, and other things, but in the bigger picture, what are some of those things that when you look forward into the future, Microsoft just acquired Activision, the gaming company, so it's clear that they're betting big. I think it was their largest acquisition. They're obviously betting big on the metaverse and in that space. But when we look out, let's say a year to 3 years out, is there something that gets you really excited, beyond obviously the forest modeling, but is there some type of technology or some movement or something that's happening that gets Dr. Liu really excited?
Yeah, I think so. I think you see, no matter what you think, like basically we are using gaming. I like gaming. I think I don't play games, but I think the gaming can be used. The gaming method can be used to solve all kind of problems. So when you have like a forest planning, it's a game. It's a game. So
That's a good point.
You play the game in a virtual view, in a digital field, in the digital world. You play the game so after you win, everybody win. Maybe it's hard how you judge that. What the objective you are. So you play the game before you do it. This is the best way to win, and then you apply in the real world. So I like a simulation and optimization, gaming. So they all can be, AI, and they all can be integrated. It's not buzzword. So we already do that, so when you do forest plan, you build a digital forest, you set the goal and set up the constraints and the variables, automatically generate a plan and tell you what you should do now to achieve your goal. And this is the future. We always has we call the digital world and real world. The two worlds, they communicate all the time. They help each other. So this is the future. I don't want to say those buzzwords, but basically we have been doing this for a long time. So the difference is we have temporal scale. We know that not only just one-time shots, or not only just show you the past, we show you the future. We let you see the future before you do it.
Yeah, very, very cool. And so I'm just thinking, as you describe it that way, Dr. Liu, in my mind, I'm thinking this must be computationally intensive, and it must take a really, really long time for these models to run. Is that true? And if so, what's an average run of a model, or does it just depend on the size of the forest or the number of variables? But is this something you like, the big Staples business store easy button, the big red button, you hit it, have a sip of your coffee, and the output's there? Or is this something that takes a bit of time to run?
Yeah, exactly. This is a very good question. You see, and 10 years ago, like you see in BC, provincial government, they have some funding to hire a consultant to find to make the first model faster. So, but most people, they try to buy the hardware. For the last 10 years, our team find a way to do it using cloud, because in the cloud, there are hundreds of computers there, right? So you can build a super computer anytime you need it. So you finish your work and release the computer. this is another important feature of cloud computing. So for us now, we already use it in our office. We have like 10 computers. We always can build a cluster, right, to finish those work. We also tested in the cloud, in Canadian cloud, in Alibaba cloud. They worked really well. But the only thing right now, we need more support to test it, to try it. But this is a technology we call easy cloud. So we develop ourselves, our team developed it. So the general idea is when you need a supercomputer, you always can build it with cloud computer. You don't need to buy those equipment. So after you finish your work, you release it. This is a very good feature.
Right, absolutely. So you're scalable at the end of the day, and you scale up and or scale out, I should say, and solve the problem. So on what's a typical average run rate? Like give me an example. If we're working in BC for a client dealing with X number of hectares, is this solved in a day, in an hour, weeks, or is there
let's say when you have 1 million polygons, you have 1,000 layers, resources, objectives. You have you consider like 200 years. So for those problems, it can, for simulation and run, it's basically 30 minutes or 20 minutes, basically, but load the data and save the data. But if you use optimization, it will take probably 5 hours to find it. But most projects not that big. You know, we have because we call spatial information. We know where the harvest blocks are. So we allocate harvest blocks. We schedule the harvest and we build the roads, everything included. So if we just don't carry, carry the spatial information like Woodstock doing, that can be really fast, a few seconds, right? Because you only play with a few variables.
Yeah, that's amazing. That's faster than I thought. When you were describing that scenario, I was waiting for you to say it'll take weeks to solve, but even 5 hours, that's reasonable.
Most projects almost take no time.
Yeah.
Most projects.
Well, yeah, because yeah.
If you have like
yeah, go ahead.
No, it's the internet has a problem.
Yeah. Well, it's amazing at the end of the day when we're doing this. So for our listeners, we also have a video component at play. Like we're doing this live with Dr. Liu in China. I'm in Ottawa, Canada here, and we're interacting. Like, again, I'm always amazed this is actually doable per se. So thinking of this piece, the vision you set, this digital forest, I love the idea. The fact that you said, some of your work can be that fast, not 5 hours, but second, like if you're not carrying the spatial, you can do things a little bit faster. There's the potential that you end up with that real-time digital forest, where you can game, run different scenarios, see what it looks like in the digital forest, and then determine whether that fits your requirements. So that's really cool. That's amazing. I'm curious to get your thoughts. So in BC, obviously, there's been some really bad forest fires, and so we think about climate change. There's a carbon component, obviously, there. But how does that fit into your world? Like, is that typically a constraint? Like, can you handle that type of scenario and maybe predict the likelihood of that happening? Is that purely based on fuel loads and other criteria, or maybe walk me through that predictive, like if you can predict the future and run different scenarios, is that something that could be predicted, the fires, and or is that just a scenario that you would model and say in the event of this happening, these are outcomes that could occur?
Yeah, so if I think I have been, I started like 20 years ago. I include the forest fire in the model, which is so I always want people to plant the forest, to include the forest fire, insects, and disease during your planning, during the planting time. So you start from trees, from planting trees, you can include that. You can have how you plant your trees, where the tree should be, what kind of tree should be, where you harvest, how you reduce the fuel on the grounds, right? Control the amount of fuel on the grounds, so reduce the fire risk. So it can stabilize the carbon. That's what I want to do. But always, people always have different opinions. So you ask some people, they say fire is part of nature. They don't want to do it. But to me, forest is for all the people, for all the wildlife, for all. It's not for one person. So you cannot just listen to one person's opinion. You have to balance. That's why we use model, to balance different values over time. So you don't have to make a decision based on one assumption, and then you miss a lot of opportunities. So yeah. like the Australia fire, released the carbon release during one summertime, more than all the fossil fuels. In BC and Alberta, not 2018 is same. It's big risk. So I'm not saying you can avoid forest fire. What I'm saying, you can plan better, reduce the fire, so you can manage better, reduce the fire. So when that fire happen, you reduce the loss. So we should start from forest fire and insect disease should be part of a forest planning.
Right. Yeah, that makes sense. So Dr. Liu, as we're winding down, I found this fascinating. I've learned a lot. I love the vision that you've set. So as we're winding down and thinking about 1, 3, 10-year horizons, are there any special technologies? Like as an example, what is aiTree, your company, investing in right now? Because obviously, by the sounds of it, there's a strong development team investing in building new features and capabilities. But maybe walk us through and again, obviously not disclose confidential secrets, but the next 1, 3, 10 year, like where are you focusing your efforts and your priorities in further developing your technologies?
So we want to change the forest modeling, the way we are doing, right? So the current way, when you do models, you collect data, you build a model, and you have a set of objectives, and you run the scenarios and writing report. That's the way we do the work. But the way I think the better way, the ideal way is it's a digital forest. It's running all the time. You only need to feed the data and you will get the result automatically. You don't need to go through the whole process. Like in BC, we have mountain pine beetle attack. A few years ago, you only need to tell the model how that change, the data change, the information change. You feed the model automatically find a way to adapt that and tell you what you should do on ground. So instead of right now, most people will collect data, and build a model, do scenario analysis, writing the report. That's the way to do. But if you already have a digital forest running there, you only feed the new data and you get the results right away. So that's the future, I think.
Yeah, very cool. Very cool. So as we wind down, I always like to sometimes ask some weird questions. But what I'm going to ask you is, if you can go back and tell younger Dr. Liu, before you became Dr. Liu, but the younger Forster that was UBC, and was to give the younger self, your younger self, advice or tips on what was coming in the next 30 years, is there certain advice you would give that young Forster to better prepare him in terms of what's to come?
To me, I just open-minded. Keep yourself open-minded. Do not be limited by what you would read on the book, in the book, or somebody told you. Keep your mind open. Just try different things. You know, this. But of course, you have to learn like AI. But do not limit. You know, it's yourself. What the AI, the real AI is. You know. So right now, the machine learning, if you just get into that field, it may be limit yourself. So just learn what the real AI is. You know, the principle, the algorithms. You see how that works. Also, the cloud computing. So digital systems. I think I still like the digital systems. This is the future. They can solve all kind of complex problems. But to build that, to be able to do that, you need some basic knowledge. Like if you just have simulation, it's not enough. You have to have optimization. So if you can integrate VR or AR, that can be better. Maybe. So a lot of things to learn. You see.
Yeah, absolutely. Well, this is the thing. I think as our listeners are listening to this podcast, they can start connecting the dots in terms of some of the key technologies you're investing, thinking about, in the direction that you're going. So as we draw to a close, Dr. Liu, how do folks get a hold of you? What's the best way? Is it website, Facebook, LinkedIn, email? What's the best way for people to reach out to you if they want to learn more about aiTree and its technology and the work that you're doing?
So the aiTree is our company's name. The website aitree.ltd. So if you Google aiTree, you always can find it. aiTree, the reason we call aiTree, we use AI to solve demand and supply problems. So using the tree methodology, it's a tree like that I don't have time to talk about that, but aiTree is our company. So if you Google that, or you just go to the website, you always can find us.
There you go. So folks, if you want to learn more about aiTree and their technology, best ways, the ever famous Google aiTree, and you'll be able to find Dr. Liu and his team and reach out and connect. So Dr. Liu, thanks so much. I know it's nighttime my side, the start of the day on your side in China. Thanks so much for making the time to speak with me. I found it fascinating. As I said, I love learning, talking to people, and I definitely learned at least 20 things, kept my mind open, learned lots of things. So thanks so much for your time. I really appreciate you joining me today.
Thank you, Kevin. Thank you.
Thanks.
Thank you. I really enjoyed it. Thank you.
Great.
See you sometimes.
Sounds good.